All right. Now we're doing FreeCodeCamp Legacy Python for everybody. Python functions. All right, so let's just get into it.
Hello and welcome to Chapter 4, Functions.
Up. Boink. All right, let's go.
This is the 4.
Let's write this down because we already know we're going to have to. Just like Chapter 1 Y program, Chapter 4 functions. We're already in Chapter 4. All right, so Chapter 4. Functions. There we go. Let's go.
Fourth of our basic patterns. We'll get to iterations next. Functions is the store and reuse. One of the things in programming is that we never like to repeat ourselves. We don't like to, if we have 4 or 5 lines of code and we're going to do the same thing later, we don't like to put the same 4 lines of code in, even if it has to do with reliability. If you find something wrong with those 4 lines of code and you got them 12 different places in your program, then you got to find all 12 places and fix them. So like collect those to one place and then call them and reuse them. And that's the
true. All right, store and reuse steps. Okay. So let's look at this. We've got def, thing, print, thing. We call these reusable pieces of code functions. So the definition of a function, a thing, the definition. All right, he's going to go over this.
Idea of store and reuse. So this is how functions work inside of Python. The first thing we notice is there is a new keyword def that stands for.
Okay, I didn't notice that even though I was looking right at it. All right, so let's write this down right here, this program. Let's grab the notes and start here. Program. And then we'll have, we'll tab it over 1. We'll bring it down 2 and tab it over 1. We'll say def thing. All right. These little parentheses right here, these 2 right here, these make it to where these differentiate like variables from functions. If you see these, it's probably a function, right? So def thing, and then we want to do inside of here, we want to print hello, and we also want to print fun. Oops. Fun, that's not it. Print. Hold on, fun. There we go. It's not a text editor. So we've got this, and then we do down here, we're actually calling thing, all right? We're calling the thing function, all right? We're also saying print zip, no, excuse me, the string zip, all right? And then we're going to also call thing again. All right. So the output's going to be like this. This is the function. This is the program. All right. Let's bring this up. And this is the output. Let's tab it over a few times. Right here. How about that? Output. All right. And the output's going to be hello. This is what's getting printed. Hello. Fun. Then we're going to do zip. And we're going to do hello fun again. Hello and fun again. All right. So this is the program this is the function we wrote. Def thing. Okay, this whole thing's the program. This part's the function, not this part. But this part is the function right here. All right. So we're defining thing the function. We're telling it to print hello and then print fun as well. All right. So now this is the rest of the program. This is where we call the function. So we're telling it to do this thing. So it prints hello fun right here. Then we're saying print zip. Let me put the apostrophe. We're saying print zip. So zip gets printed here. Then we call the thing again where it says hello fun again. So this is the function call. This is part of the function call right here. This is the zip in the middle, and this is the function again right here. Hopefully that makes sense. We'll go over it plenty.
For defined function. And the def is like an if statement, or we'll see for def Python. The first thing we notice is there is a new keyword def that stands for defined function. And the def is like an if statement, or we'll see fors and whiles, that they end in a colon, and then they have an indented block, and then the indented block de-indents, and that's the end of the function.
True.
And so
this is the whole, this whole thing is the function block right here.
So there's two statements make up this function. The key thing that you have to understand and get used to is this def part is actually not running any code whatsoever.
True.
It's actually remembering the code.
True.
And that's what I call the store phase. The def creates a bit of code and records it like a macro, although it's much more complex than a macro.
True. Okay, yeah. What he's saying is this thing, it doesn't run unless we call it. We have to call it with this thing. This is called a function call. This is just the function itself, what's going to happen when we call it, but this doesn't do anything. This right here is what does something. This does something, the print, and then this does something right here. So when we call it, that's when it does stuff.
Macro. And it names it whatever you chose. You gave it a name. We named this one thing. And so it, as a side effect of Python reading or parsing these three lines, it doesn't do anything, but it remembers. These two lines are what you would like to run when you invoke thing. So this is the definition of a function, and this is the invoking of the function. But
I don't know why they call it invoking, other than they've got a ridiculous love of wizardry, but that stuff's not real. It's calling a function, right? You don't want to call it invoke unless you want to get people calling you Harry Potter behind your back. Calling a function.
So this doesn't do anything. So there's no output here from that stuff right there. But then what happens is you invoke it. And this thing looks like it's part of Python, but you in effect have extended Python with your def statement. And so when it sees thing, it goes up and runs your code. And so out comes hello fun. And then it comes back and goes to the next line, does print, so print comes out. And then it goes back and like, oh, this is the reuse part, but we get to reuse it. We define it once and we use it twice. Then it runs this code again, and then goes to the next line, and it's all done. So this little bit came out twice. And of course, this is really simple so that I can fit it on a page, but you get the idea that I don't want to repeat. This might be, 15 to 100 lines of code, and I don't want to type those over and over again.
True.
So I say, hey, store these in a name that I choose, and then when I invoke them, bring them back and run them again. Okay? So that's the basic idea. We actually have already been...
All right, let's go through this. Where's the notes? There's that. So now let's come down here and let's say Python functions. Python functions. All right. There are two kinds of functions in Python. All right. We've got built-in functions, built-in functions that are provided as part of Python, such as print, input, type, float, int, etc. All right. And then there are also functions that we define ourselves. All right. And then use. Very true. All right. So we treat the built-in, in function names as new reserved words. True. So i.e., I forgot what IE means. We avoid I mean, like what it actually means in Latin. We avoid them as variable names. But yeah, that's what's up. All right, so let's see what he says.
Been using functions from the beginning. The print is a function, right? Print is a function.
True.
Every time we see print, P-R-I-N-T, parenthesis, and then we have some stuff in here, we are calling the print function. This is the syntax with two little parentheses, is the syntax for functions. And so input's a function, type is a function, float's a function, int's a function. All these things are built-in functions that come with Python at the moment that we started. I mean, it's just we installed Python and these came along. And then there's other functions that we define and use, and that's what the def is for. And in effect, we can create new reserved words of our own making that extend the Python language after we define the function.
True.
So it's just this bit of reusable code that takes...
All right, let's write this down. Function definition. Function definition. One day I'll be able to hit that every time. In Python, a function is some reusable code that takes argument parentheses s as input, does some computation, and then returns a result or results. True. All right. So the hard word in this sentence, if you've never seen it before used in this context, is argument. All right. Argument is the input. All right. Like whenever we did like print basketball. Is it one word? Basketball. Print basketball, something like that. This basketball inside of here, this is the argument. All right. We're also going to go over these things called parameters, but we'll do that in a little bit. We don't have any examples of it. So, but this whenever there's a function call, the words or numbers or values, we call them the values inside of the parentheses, those are called the arguments. All right. Let's go to the next part. We define a function, and I'm not don't expect yourself to remember this stuff. It's just good to hear the word argument over and over and over again, because sooner or later you will know exactly what's being said when somebody's talking about arguments. All right. We define a function using the def reserved word. True. We call, I'm not calling it invoke, the function by using the function name, parentheses, and arguments in an expression. All right. Is that okay? We call the function by using the function name, parentheses, and argument in an expression. Exactly. Or sometimes we don't need to call, we don't need to put an argument agent like the quit, like yesterday when we did the quit function inside of that one thing. Sometimes we don't need an argument, all right? It doesn't matter. But fact is, that's how we do it. We call it by using the function name, like print. Then we have the parentheses, and inside there, we put the argument, okay? Let's go.
Take some arguments. We haven't seen any with arguments. There's a little parenthesis, and we'll see how that works in a bit. We define using the def keyword, and then we invoke it. There's the defining phase, which actually doesn't run the code.
Remember at the beginning when this guy had that on his stupid Harry Potter hat? Bro, this guy's going to be saying invoke every single time. I guarantee it. These guys love believing they're magicians. No, you're not. You just didn't go to the gym a lot, bro.
But it just remembers the code, and then there's the invoking phase. You define it once, and then invoke it one or more times. Calling the function or invoking the function, we think of those two things as the same thing. Call, invoke, or just the terms we use. Most people just say call the function, but invoking it is a perhaps more descriptive way to think about it. So here's an example of a function.
All right, let's look at this before we go further. All right, so we've got the argument. It's just like what I said in the last thing. We've got big equals max hello world. So max has already been defined. This is a what are we trying to say? This is a built-in function that finds the, I guess it's going to find the largest letter by, I don't know, by assigning numbers to each one of these letters, right? So it's going to give us, so max of hello world is going to give us W, since W is the furthest along. If there was a Z here, it would put the Z there. If there was a capital Z there, it would put the capital Z over the lowercase z, because in the list of letters, the capitals come after the lowercases, all right? That being said, so if we did this here with the max and it gives us W, and then we say print tiny, and tiny equals a min, which is the opposite of max, hello world, it would probably print E, because E is in front of all these, right? It's the fifth letter of the alphabet, while A, B, C, and D are the ones before it, and there's no A, B, C. Oh, no, there's a D right here. So D would be in the front of this one, more than likely. Let's see.
It is built into Python. It's called the max function. And we can pass some parameters into the max function. So we pass the hello world string. Now, like much of Python, max knows what kind of thing is being passed into it, and it knows that it's looking for the largest character, the lexicographically largest character, and in this case, it scans this little, that's inside the max code, it scans through and finds the largest character. So apparently, lowercase letters are high.
Okay, so lowercase are higher than uppercase, according to him. So uppercase are gonna, pardon me, lowercase are before, are after, lowercase are after uppercase. So it would be all the capitals and then all the lowercase in that list, all right? So I guess the capital H would probably be the lowest one in this one, since it's doing the min. All right, so let's keep going.
Higher than uppercase letters, because in English, we get back a W. And so this is what's called the return value. So this is an assignment statement. Let me clear this and start over. So this is an assignment statement, so it has to evaluate this right-hand side. And a function call is nothing more than like x plus 1. It's something to evaluate. It runs the function code, passes in this argument, and then this residual value, this is called the return value, we'll look at this in more detail, becomes the result of this little bit in the expression, and there's nothing else.
So yeah, because of this function call right here, whenever we call big, no matter what, because of this specific hello world being inside this max function, no matter what, big is going to equal W. So we could say hello space plus, we could say print hello space plus big plus hello plus plus ORLD, and it would give us hello world. Let me show you. Hopefully this makes sense. We could do something like this. We could say print hello. We could say, no, let's put a space there. We could say big, and we could say world, space ORLD, like this. Like this. Okay. And this would say hello world if we said something like this. Big equals, what does big equal? Max hello world. Max hello world. Okay, so let's say this, we do this and do this, and then the output would be hello world, like that. All right, so that's what would happen in this case right here, because this big equals W. This is W. All right, So we would say hello space and then big and then world like this, and it would concatenate it all together and give us hello world, right? Blah.
Could have, W+1 or something. And then the W is what's stored into big. Okay, so we print big, and big is a variable that has the letter W inside of it. And then we ask what is the smallest, and that finds the blank, and so we get a blank to see this. There's a min function, max function.
I thought that this was looking for the H. No, the space is even lower than H or capital letters. Okay, I see. Okay, so let's get that out. No, it's not that.
Both of these.
Chill. All right. UTF-16 list. All right. Most of you, if you've never seen this before, there's this UTF-16 characters list right here, and you can find out all the UTF-16 characters you feel like. And we can see here's a bunch of characters. We're looking over here. Here's a bunch of characters, and this is the list that they go in. You can see this is 224 right here. This is 221. All right, we come down here. Where's regular letters? Where's the regular letters? Here's the capitals. Those are smaller than the see, we got like 50, pardon me. We got 57 here, then we've got 61 on A, on lowercase a. And wherever the space is, here's the space right here, which is 20. So yeah, this comes before all that stuff. All right, so let's go.
Are built in. These are built-in functions. They're always there for us. Okay.
Let's write this down. Where are you, Notepad? Here we go. All right, so we're done with this. Let's come down here. Pardon me. What do we write? Max function. Max function. All right. So what do you say here about this? What? What? A function is some stored code that we use. A function takes some input and produces an output. What? Okay. Max function, we'll just write this. Finds the largest value passed in from an argument. Finds the largest single value. Passed in from an argument. All right, let's just say that.
So here is another example of the max function. And so we can think of this as invoking or calling this function as this right-hand side is being evaluated. We are passing this variable in, and there's some code in here, and it's going to do some stuff, yada, 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 and then it's going to give us back a bit of stuff. And that's its return value, and then that goes up into the big, right? And so that's how this works. And so this is actually built in or burnt in, I guess I can't draw. And so you can think of this as sometime a long time ago when Python was being first formed, somebody wrote some code. And it's got some stuff in it. It's got a little loop that reads through all the letters. It has to figure out if it's a string or a list, etc., etc., etc. But this is store, except you didn't do the storing because it's already built in. And then this is the reuse, store and reuse. So we build these things into Python. They're already pre-built, as if before the first line of your code executes, way up here, someone put all this code in for you into Python and created a thing called max.
Yeah, that's what happened. Because there's, at some point, you go close enough to the actual machine itself, and then you'll learn machine code. I guess that's what it is. And when you get to the, like, right up next to, when you start having to manipulate the actual machine itself, like the actual ons and offs, then you're not going to have any kind of built-in anything. You're going to have to build them all yourself. But I mean, this thing, we've been doing this for what, 70 years now. maybe even over 100. I don't know. We know how, we as in collectively humanity, we know how to create functions at this point. So let's go.
For you. Now we've been using this already, built-in function.
All right, let's do this. Type conversions. Type conversions. Pardon me. All right. So when we put an integer and a floating point in an expression, all right, the integer is implicitly converted to a float. I thought we already went over this. Well, whatever. Second time we heard about this. All right. So also, we can control this with the built-in functions int, yes, and float. And we've been doing that. All right. So let's go.
We've got type conversions. We've got like the float that takes a integer and returns a floating point version.
I guess this thing's showing us functions. So this is the built-in function. 99 is the argument, right? So this is going to turn it into 99.0. So 99.0 divided by 100 is 0.99. True. So we've got I equals 42. What's the type of I? It's an integer because there's no decimal point, so it's not a float. So if we say change F to float, make F into float I, all right? And then print F, it's going to give us 42.0 because we just turned this F, we turned this 42, we made this F become 42, but float, all right? So this is still a float, but I is still an integer. We didn't actually change I itself, all right? So when we print 1 plus 2 times float 3 divided by 4 minus 5, we're going to have 6.0 divided by 4. So what is that? 1 1/3, I guess. 1 1/3 minus, so 1 1/3 plus 1, so 2 1/3 minus 5. So -2. Whoa. Oh, so there's no thirds. It's a freaking halves. Whatever. Anyway, so it's going to be, what is this? 6.0 divided by 4, which would be 6.0 divided by 4. It'd be 1.5? Is that it? Oh, 6.0 divided by 5. Anyway, 1.5? Is that what it is? What? Oh yeah, $1.50 times 4 would be $6. Yeah. Okay, so 1.5. So 2.5, -2.5. I feel okay. So 6 -1.5 plus 2.5 minus 5 would be okay. All right.
And that,
all right.
Again, this is kind of like an expression. So it's like I want to divide this by 100, but before I do that, I've got to convert it to a float. So it has to sort of do these function calls as it's evaluating the expression. Okay. Sometimes, like here, we just have a prints out the return value. That's what this is. This is the return value. If you just type a function in a parameter, it can be in a constant or it can be a variable. And as we'll see in a second, we'll give you many of these if you like. So you can either just run it or take the result of this. This passes an integer in, converts it to a float, and then puts the float into that. Type tells us what kind of thing that is, and you can use this inside of an expression. And so it's like, what am I going to do first? Oh, I've got to do 2 times this thing. Oh, wait a sec. Pause just briefly for a moment. Call out to some float code. Pass a 3 into it, and then something comes back, the return value. the residual value comes back, and then that participates, in this case it's going to be 3.0, participates in this 2 times 3.0. Okay, and so 2 times 3.0 then ends up being 6.0, et cetera, et cetera. But you can see as it's like, oh, wait a sec, I got to figure out what this is, call the function, get the return value, and then continue processing this expression.
True.
We've also done this with...
All right, let's write this down. Hopefully I won't get too confused on this one. That's hoping. All right, so let's see. String conversion, right? String conversions. String conversions. We can also use int and float to convert between strings and integers. We will get an error if the string does not contain numeric characters. True. All right, let's see what this is. All right, cool. So we got sval equals, I hate these names, honestly. Sval equals 1, 2, 3. So type of sval is going to be class of string, because this is a string, right? Print string plus a string, which this is, plus 1. It's not going to work because strings cannot be added. I mean, numbers cannot be added to strings and vice versa, right? So that's why it says type error, line 1 right here. Find stand-in. Line 1. I thought it was line 1, 2, 3, 4. Well, whatever. Eval equals int sval. So we're turning this thing into ival. I keep saying eval, right? So ival equals int sval. Like Ivan, right? Like Spanish. Int sval. Okay, so this is now 1, 2, 3, the number. Okay, so it says class integer. So we say print ival plus 1. It'll give us 1, 2, 4 because it's 1, 2, 3 plus 1, right? So NSV equals hello Bob. We say niv equals int NSV. I hate these names, honestly. It won't work because we cannot change this string of letters into
string conversion.
Into a what is it? It won't work because this string of letters can't be turned into an integer because it's letters and not a string. And so it says line 1. I'm pretty sure line 1, according to this, is whatever's right here. Okay, because this is line 1 here and line 1 here. All right, so let's go.
Versions, partly because, just as an example, the input always returns a string. The input function returns a string. And so, you know, here's this string, could be coming from input, but we'll just take 1, 2, 3. We know that that's a string. It's not the number 123. And if we try to add 1 to it, we get a trace back. Cannot concatenate string and integer. Trace back. But we can't convert that string to an integer. And so int can take like a floating point number or an integer or even a string, and it says, oh, I know what I'm supposed to do with a string. I'm supposed to look at this, interpret these as numbers, and, you know, multiply by 10 and figure out what the hundreds place is and all that stuff. There's a little bit of work to that, and it does it. But then it gives us back an integer, and we say, oh, what is that? That's now the 123, but it is of type int. And now we can add 1 to it and get 124. And as before from this example that we're kind of reusing from a previous chapter, you don't want to try to convert, oops, sad face, sad face. Sad face. Don't want to try to convert something that doesn't have digits using int because it'll say, I don't know what to do, and then your program quits, right? You don't want your program to stop, tracebacks, and you can, of course, deal with that with try and accept, but that's like a previous lecture. Okay, so up next we're going to talk about building our own functions, not just using the predefined ones.
True. Awesome. All right. Time for some smooth jazz. All right, so there's that. So let's do this. What is the purpose of the def keyword in Python? Of course, it's slang that means the following code is really cool. Indicates the start of a function. Of course, it indicates that the following indented section of code is to be stored for later. I mean, technically. It indicates the start of a function in the following indented section of code is to be stored for later. I guess this one too, but I think let's go with this one. Come on. Okay, so it was the last one. Although, whatever. The start of a function or the start of a function declaration. I guess that's what it meant. It indicates the start of a function and the following indented section of code is to be stored for later. So that's the answer. Check the answer. Looks good. And submit it. All right. So now we're on to build our own functions. And we got an exercise with this one. And we'll see you next time.